Today we are going to talk about an option to quickly test new ECU functions and controls without needing to know a lot about software integration. This will enable faster testing in your development and validation work with EHOOKS bypass. Starting with, what is EHOOKS? EHOOKS is a technology from ETAS which allows for quick changes of existing ECU software without the need to modify any source code or require development's time. Changes could be as simple as making a measurement variable calibratable or as complex as adding a whole new function, including additional external sensors, either by changing or overriding an existing function on target, or by running our external bypass hardware like the ES830 shown here. Let's have a closer look at a single ECU function to see how EHOOKS works. In our example case, let's assume the function has a single input and a single output. Neither can be changed via calibration in Inca since they are both measurements. In this case, the user decides to change the input of that function. Therefore, he or she selects the variable from the A2L file in EHOOKS and configures it as a calibration bypass. EHOOKS then patches the existing software and inserts a calibration hook for the selected variable. Besides calibration hooks, there are various other possibilities, and literally anything inside the ECU software can be hooked with EHOOKS. After the EHOOKS configuration is complete, a new A2L and hex file for the hooked software are created, which can be flashed into the ECU. The hooks are controlled and calibrated via Inca just as any other calibration value. Now that we are past the concepts, let's look at a more applied example, injecting noise into a sensor input. Here we have the normal input from a sensor represented by a sine wave. This represents what may be physically possible without a hardware failure. You can see that the bypass state is in a waiting state. Now to add our noise signal to the sensor input. First, change to the working page and then enable the bypass. The state of the bypass is active, and the design noise is now superimposed on the sine wave. This is the actual real-time value on the controller and is quite useful for proving real-time robustness in diagnostics and control designs. After disabling the test, you can see that the noise goes away. EHOOKS can be modified via script MCD3 or ASAP3. Giving you the ability to run a test fully automated. While this example shows a sensor input, there is also the ability to override an actuator output or other intermediate calculation variables once the hooks are properly prepared, thus giving you capability and flexibility to verify and validate a design. Here's what we've learned today about EHOOKS bypass. Contact ETAS today to see if EHOOKS can benefit your software development project. Thank you, and have a good day.